My name is Abdul Al-Shawa.
My name is Abdurrahman Qazi.
My name is Ramsey Cater, and we are the power beaters.
People in developing countries lack access and the ability to create reliable and cheap power. And with the increasing demand for smartphones and the lack of an infrastructure to create electricity, it is important that they have this need addressed.
It is often the case that farmers within these developing countries would beat bags of grain into flour. It is our plan to harness this mechanical energy into electrical energy.
So we've created a product called the Power Beater, which utilizes a piezoelectric sensor, which with our design that we made throughout this course, you can harness that power and use it to charge a battery.
Upon the battery being charged, this energy can be traded and sold amongst people. This can bring people together to work on teams and strengthen the economy of the country.
Hi, I'm Zain, and I'll be talking about conceptual design for solutions.
As you can see here, our system takes in mechanical energy in form of someone beating the bag that has the sensors embedded in it. The sensor then converts this energy into electrical energy, which is in AC form, which is then sent into the bridge rectifier using a relay to convert it into DC. This is then sent into a combination of a regulator and a capacitor to further smooth out the signal so we have a constant DC voltage. This DC voltage is then stored in a battery. We also have a feedback loop here that senses the level of the battery to tell us when the battery has been filled. When the battery is fully charged, the voltage sensor sends a signal to the relay to turn it off, and the sensor stops taking in more electrical energy.
About the detailed design for our system, and me and Akshat here will be going over how we can actually implement the system. So the first thing is we should look at some of the properties that our system needs to have. For safety issues, our system needs to have very low water absorption, because with high water absorption, it could potentially damage some of the electrical components that is present in the bag, and which could lead to some major safety issues. Secondly, our system needs to be small enough such that the sensor is able to put the sensor into a cotton fabric, into a mesh of cotton fabric. And the third thing is our system will also have to have enough battery power and enough energy, supply enough energy such that it's able to provide at least 1500 milliamp hour of energy, which is what a typical cell phone uses. Now Akshat will be going over some of the properties of the piezoelectric sensor that we have found from some of the suppliers that we have talked to.
So we got a really nice supplier, Songchuan from China, who supplies us with the exact things that we need. Now this will have high durability, and it'll be cheap and strong, and it should provide us enough power. It supplies us with 1500 milliamp hour of energy and 3.8 volts for a supply of 5.7 watt hour of energy.
Yeah.
And that is much lower than the average mechanical energy that we need.
Yeah.
That should be good enough.
Yeah. And the best thing about this is it's actually very feasible, because at the same time the sensor is just 55 millimeter by 33 millimeter in dimension, so we can easily mesh it inside a cotton fabric, okay, and in a way such that the sensor is enclosed in the cotton fabric, and we have our system up and running like that. So as you can see through our detailed design that our sensor is very feasible, and it can provide enough energy by supplying the average mechanical energy a person would generate by beating the bag.
So now let's talk about the ethical considerations in terms of designing this product. First of all, there's safety considerations. We need to make sure that the circuit is free of electrical or fire hazard. The circuit should be designed in a way that it prevents short circuit situations from ever happening. Second, there is environmental considerations. The recycling of the battery should be made readily convenient, and the battery itself should be very simply removable.
Socially, we wanted the people to be able to trade the power they generate, so we made the battery really portable and easily detachable from the device. A cultural aspect of this product is, due to the lack of technical knowledge in the area that we deployed this product in third world countries, the device usage must be self-explanatory, and it shouldn't require any recalibration, or much technical maintenance. Lastly, from an economic perspective, knowing that this device is being used by those who make flour from beating bags of grain manually, this device must be inexpensive and easy to acquire.